Okay, this will be the last video in section 4.2. We're working on compound interest. In example 5a, uh, Becky must pay a lump sum of $6,000 in 5 years. What amount deposited today at an annual interest rate of 3.1%, compounded semi-annually, will grow to $6,000 in 5 years? Okay, so let's see here. Probably best if we start by making a list of the things that we know and also what we're trying to find. So if she's going to pay a lump sum in $6,000, then that is the future value A. So we know that A is $6,000. And we know she needs to pay that in 5 years, so that would be the time t. What amount deposited today? So that means we need to find the principal or the initial value p. So let's write find p down here at the bottom. And so then we must be given the interest rate, 3.1%. R is 0.031. Make sure you always convert your percentages to a decimal when you're using this formula. Just move the decimal point 2 places to the left. And then if we're compounded semi-annually, then semi-annually means twice per year, then n is 2. And so we can put these numbers into the formula and solve for p. So A is 6,000 is equal to p times 1 plus R is 0.031 divided by 2 raised to the n times t, which is 2 times 5 or 10. So what I'd like to do is I'd like to go ahead and simplify inside the parentheses. 31 divided by 2 is 15.5. So that would be 0.0155. You can do that with a calculator, and you can add 1 onto that and get 1.0155, and then raise that to the 10th power. And then if we're going to solve for p, what I'd like to do is wait to do more calculations on the calculator. I'd like to get the exact value of p first. So I'd like to divide by 1.0155 to the 10th on both sides. And then I have p is equal to 6,000 divided by 1.0155 to the 10th. And I need to be careful when I put that in the calculator that I don't have some rounding error. So I need to raise, well, let's just look at the calculator together here. So I think I have one pulled up. And so we need 1.0155 raised to the 10th power. Notice I used on this particular calculator, this is at desmos.com/scientific. There's a button AB. You should have a similar button on your scientific calculator. You can press enter and get this number right here. And then we need to do 6,000 divided by that. So let's go ahead and type in 6,000 divided by, and then in order to get this answer, this previous answer from memory, we're just going to press the A and S button, which you should have in your calculator. Your calculator may not display the number, it may just display A and S, but we can hit enter, and there's our answer, $5,144.60. And again, the assumption is we'll round to the nearest penny. So 51.44 51.44 and we can box that up. Okay, the next problem says suppose only $5,000 is available to deposit now. What interest rate is necessary for the money to increase to $6,000 in 5 years? So, so let's see here. The future amount is still 6,000, but now the initial value, the initial amount is 5,000. And the interest rate is what we don't know. We're going to solve for R. And so we know that T is 5 years. And we know that the interest is compounded semi-annually, so N is 2. So we can plug these things into our formula. Remember, our formula starts out with A equals. So 6,000 is equal to the initial amount, 5,000, parentheses, 1 plus R over N. R is unknown. N is 2, raised to the N times T power, 2 times 5, or 10. And so we're going to solve this for R. And could be a little tricky, but I think we'll get through it okay. So let's just go ahead and start out. Let's divide by 5,000 on both sides. And if you think you already know how to solve this equation for R, I encourage you to stop the video and try for yourself. 5,000s cancel. And we're left with 6 over 5, right? 6,000 divided by 5,000 simplifies, is equal to 1 plus R over 2 raised to the 10th power. And so if we want to isolate R, the next thing we should do is we should take the 10th root of both sides. So we'll get the 10th root of 6 over 5 is equal to 1 plus R over 2. We can subtract 1 on both sides. The 1's cancel. And we'll have R over 2. Maybe I could go ahead and switch the two sides. Put R over 2 on the left, and then put the 10th root of 6 over 5 minus 1 out on the right side. And then to get R by itself, we just need to multiply both sides by 2. Multiply by 2 over there, and then multiply by 2 right there. And maybe I'll even back up, sorry, for just a minute. Maybe I'll just back up and make a note. I took the 10th root on both sides, and the 10th root and the 10th power canceled each other out. Okay, over here, the 2's cancel, and we're just left with R is equal to the 10th root of 6 over 5 minus 1, and all of that is multiplied by 2. So let's go to the calculator and practice one more time on that. We can type in 6 divided by 5 for starters. That would be 1.2. And then we need to take the 10th root of 1.2. So there are two ways to do it. Let's see, I have a button here that says the nth root, and it gives me an opportunity to type in the 10 there. And then let's see, maybe I can just go like that and then type in 1.2. You might have to play with it a little bit on your calculator. There's actually another way to do that you might be easier on your calculator. You could do 1.2 and then the exponent button, and then the 10th root is the same as the 1/10th power. So you could type in the fraction 1/10, or maybe it's easier to type in the decimal 0.1, and then you'll get the same answer either way. Okay, and then we were supposed to subtract 1. And on some calculators, when you type minus 1, A and S comes up automatically. In this calculator, it didn't. So let me go back and type A and S, and then minus 1, enter. And then that needs to be multiplied by, let me, ANS multiplied by 2 and enter. And so here's our answer, 0.0367. And let's see, the problem doesn't tell us what to round to. Let's round to 2 decimal places. Now, that's on a percentage, right? So the decimal point needs to go 2 places to the right. So we'll have 3.6798. And then if we round off to 2 decimal places on the percent, that would be that 7 rounding up to an 8. We'd have 3.68%. 3.68%. So R is approximately 3.68%. Practice on the calculator to make sure that you can get that answer. Okay, one more thing I want to show you. There's another formula for compound interest. The idea is that we are going to compound the interest continuously now. And so that might seem a little strange. You know, what we found is that the more often we compound our interest, the more money we make. So what's better than compounding twice a year or 4 times a year? Would be 12 times a year, would be every month. What's better than that? Compound every week or every day, for instance. If you compound every day, then N is 365. What's better than that? Well, what if you compound every hour or every second or every half second and so on? And so, so what's the effect? If we just compound more and more often, could we have an infinite amount of money after some fixed time? Could we take our $1,000 investment and turn it into $1 billion in 10 years if we just compound often enough? Well, the answer is no. There's something called a diminishing return. As we compound more and more often, we get less and less back out of it. And so then what's the most often you could compound? You could compound continuously, which leads us into this formula. I won't show you where it comes from, but we'll use it. The formula says the new amount A is equal to the principal, the initial value multiplied by E raised to the RT, where E is a very special number called Euler's number. It's approximately 2.72. And this number is similar to pi in that it's an irrational number. It has a special symbol to represent it, and it's important in lots of mathematical applications. So let's give it a try. So in example 6, these are actually the same numbers as example 4 in the previous video. $1,000 earning 4% interest for 10 years. But now the difference is the interest is compounded continuously. When we get our answer, you might want to go back and compare it with the answer from example 4. Okay, so the principal P is $1,000, and the interest rate is 4% or 0.04, and T is 10 years. And so we want to find the future value A. Okay, so we'll just plug in. We'll do A equals 1,000 times E to the RT, 0.04 times 10. 1,000 times E to the 0.04 times 10 is 0.4. And then we need our calculator again. So let's go back and look at that calculator one more time. We should have a button for the number E. and I don't see it here, so let's see if we can find it somewhere else. That's a keyboard. That's probably not going to help. Here's, aha. So there's a button E to the X. You might have a button, a similar button, E to the X, or you might just have a button for E and then use the exponent after that. In fact, it might be fun if we just went ahead and typed in E to the first power right now, so we could see that special number, 2.718, etc. And what we wanted in our problem was E to the 0.4, and then that should be multiplied by, that answer should be multiplied by 1,000 to give us $14.91 and 82 cents. $14.91 and 82 cents. $14.91 and 82 cents. And we can box that up. In part B, how much of that is interest? That's just a subtraction problem. The total amount, $14.91.82, minus what we started with, which was 1,000, gives us the interest earned, $4.91 and 82 cents. And there we have it. We'll see similar problems later in this chapter. So look for those, I believe, in section 4.6. That's all for 4.2.